Welcome students. I am Dinesh, working as Assistant Professor, Government First Grade College, Sagar. Dear students, in this video lecture, I am going to explain the circularly polarized light and elliptically polarized light. Dear students, in the previous class, we shall discuss about the topic, the basic concepts of polarization of light and Huygens principles. Today, I am going to explain the circularly polarized light. Let us see the circularly polarized light. See here, if the vibrations of the particles of the medium are circularly with constant period and takes place in a plane perpendicular to the direction of propagation of light, then the light is said to be circularly polarized. Here in this case, the amplitude of vibrations remains constant but the direction changes. ಇಲ್ಲಿಷ್ಟೇ ಈ ಮೀಡಿಯಂನಲ್ಲಿರ್ತಕ್ಕಂಥ ಪಾರ್ಟಿಕಲ್ಸ್ಗಳು ಅವು ಕಾನ್ಸ್ಟೆಂಟ್ ಪೀರಿಯಡಲ್ಲಿ ವೈಬ್ರೇಟ್ ಆಗುತ್ತೆ ಮತ್ತು ಈ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಪ್ರೊಪಗೇಷನ್ಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ವೈಬ್ರೇಟ್ ಆಗ್ತಾ ಚಲಿಸ್ತಾ ಇರ್ತದೆ. ಇವು ಸರ್ಕ್ಯುಲರ್ ಶೇಪ್ನಲ್ಲಿ ರೊಟೇಟ್ ಆಗ್ತಾ ಚಲಿಸ್ತಾ ಇರುತ್ತೆ. ಹಾಗಾಗಿ ಇದನ್ನು ಸರ್ಕ್ಯುಲರ್ಲಿ ಪೋಲರೈಸ್ಡ್ ಲೈಟ್ ಅಂತ ಕರಿತೀವಿ. ಈ ಡಯಾಗ್ರಾಮಲ್ಲಿ ನೋಡಿ ನಿಮಗೆ ಗೊತ್ತಾಗ್ತದೆ. ನೋಡಿ ಇಲ್ಲಿ EX is perpendicular to EY. Both are perpendicular to each other here. This is about circularly polarized light. Moreover, here it is also said to be the superposition of two plane polarized waves. Superposition of two plane polarized waves under certain conditions gives rise to a resultant wave whose light vector rotates with constant amplitude. The tip of the vector tracing a circle. Here. Such a resultant wave is called the circularly polarized light. Let us see the elliptically polarized light. Here, if the vibrations of the particles of the medium are elliptical, with constant period and takes place in a plane perpendicular to the direction of propagation of light, then the light is said to be elliptically polarized. Here in this case, the amplitude and direction of vibrations of the particles of the medium changes here. Here, if the magnitude of the amplitude of the light vector varies periodically during its rotation, then the tip of the vectors traces an ellipse and the resultant light is called the elliptically polarized light. See here in this diagram, linear and circular polarization. The sum of linear and circular polarization that gives elliptical polarization. Here the A cos beta and A sin beta, these two vectors are perpendicular to each other. Here amplitude and directions of vibrations of the particles of the medium changes here. This is about elliptically polarized light. Let us see the retarding plates. What are retarding plates? Retardation plates are the devices used to produce path difference between ordinary and extraordinary rays. A doubly refracting plate cut such that the optic axis is parallel to the refracting phase and the thickness of the plate is such that it produces a certain phase difference between the ordinary and extraordinary rays is called a retarding plates. There are two types. One is the quarter wave plate and the other is half wave plate. These are the two types of retarding plates. The quarter wave plate and half wave plate are called retarding plates since they retard the motion of one of the beam. ಇಲ್ಲಿ ಕ್ವಾರ್ಟರ್ ವೇವ್ ಪ್ಲೇಟ್ ಇರ್ಬೋದು ಅಥವಾ ಹಾಫ್ ವೇವ್ ಪ್ಲೇಟ್ ಇರ್ಬೋದು. ಇವು ಒಟ್ಟಿಗೆ ಒಂದು ಟೈಪ್ ಆಫ್ ಬೀಮನ್ನು ಸ್ಟಾಪ್ ಮಾಡ್ತದೆ, ರಿಟಾರ್ಡ್ ದಿ ಮೋಷನ್ ಆಫ್ ಒನ್ ಆಫ್ ದಿ ಬೀಮ್ಸ್. Let us see in detail in the next slide about the retarding plates. Let us see the theory of retarding plates. Theory of retarding plates. See the diagram. A double refracting plates cut such that the optic axis is parallel to the refracting faces, and the thickness of the plate is such that it produces a certain phase difference between ordinary and extraordinary ray is called retarding plate. Let a beam of plane polarized light be incident normally on a calcite, that means negative crystal plate, cut such that the optic axis is parallel to its refracting face, shown in the diagram here. Let the linear vibrations in the incident light be along PQ, making an angle theta with the optic axis. It makes an angle theta with the optic axis. Let A be the amplitude of vibrations in the incident light. A be the amplitude of vibrations in the incident light. See here, on entering the crystal, the light gets splits into extraordinary and ordinary ray. Here, shown in the diagram here, when the light entering the crystal, it splits into extraordinary ray and ordinary ray. The amplitude of vibration also gets splits as A cos theta along PE. A cos theta is taken along PE and A sin theta is equal to B, that is along PQ. Here B is taken along PQ, A is taken along PE. A cos theta has vibrations. A cos theta, that means along PE, has vibrations parallel to the optic axis. Here line shows, number of lines shows here, that is optic axis of the crystal, and constitutes the extraordinary waves, whereas the component A sin theta along PQ having vibrations perpendicular to the optic axis constitutes the ordinary wave. When light leaves the crystal, the two waves have a phase difference of pi between them owing to the differences in their velocities. Since calcite is a negative crystal, the extraordinary ray advances over the ordinary ray by a phase angle pi. Let x equals a sin of omega t plus pi. Let it be equation 1. Let x equals a sin of omega t plus pi, where pi is the phase angle between extraordinary and ordinary. And y equals b sin of omega t. Let it be equation 2, represents the extraordinary and ordinary wave respectively, where x and y be the displacements of the particles at any instant. The nature of the resultant wave on emerging from the plate can be obtained as, first one, x upon a equals sin of omega t plus phi, and y upon b equals sin omega t. Therefore, x upon a equals sin omega t into cos pi plus cos omega t into sin pi. And expanding sin of omega t plus pi, we get this equation, where x and y be the displacements of the particles at any instant. See here, x upon a equals sin omega t into cos pi plus, here cos omega t is written as trigonometric function is given by square root of 1 minus sin square omega t into sin pi as it is. Here we know that cos theta equals square root of 1 minus sin square theta. According to that condition, we can replace cos omega t by square root of 1 minus sin square omega t into the sin pi. Here x by a equals y upon b cos pi, y upon b cos pi plus square root of 1 minus y square by b square into sin pi. Here sin square omega t, here in this equation, second equation, and squaring of this equation, here y square by b square is equal to sin square omega t. Here for sin square omega t, you can substitute y square by b square. Here sin omega t into cos pi. Here for sin omega t is y by b, y upon b into cos pi. Here for sin omega t, you can substitute y upon b into cos pi as it is plus square root of 1 minus sin square omega t. For sin square omega t, you can substitute y square by b square sin pi as it is. And further simplification of the equation, here x upon a minus y upon b into cos pi equals square root of 1 minus y square b square, y square upon b square into sin pi. In the previous equation, we can y upon b cos pi, when it comes across LHS of the equation, it becomes minus, then the equation becomes in such a way. Squaring the above equation on both sides, we get x by a minus y by b into cos pi whole square is equal to 1 minus y square b square into sin square pi. Squaring of the above equation, this equation, we get this equation here. Here, on expanding and further simplification of this equation, we get x square by a square plus y square by b square into cos square pi minus 2xy by ab into cos pi. Here the expansion of this one, LHS, this is in the form of a minus b whole square. A minus b whole square means a square plus b square minus 2ab. According to that, we can expand this one, we get LHS of the equation like this. This is equal to, on RHS side, on RHS side, just you multiply sin square pi, here sin square pi into 1 sin square pi minus y square by b square into sin square pi. On further simplification of the above equation, here we can transfer this equation like this. Here y square by b square into cos square pi, when it comes across RHS of the equation, and take common y square by b square, then it becomes sin square pi into cos square pi. Sin square pi into cos square pi is equal to 1. Therefore, this equation becomes x square by a square plus here y square by b square minus 2xy by ab into cos pi equals sin square pi. Here this minus y square by b square into sin square pi, this one y square by b square into cos square pi. On further simplification of these two, we get y square by b square here. Let it be equation 3. This is the general and ellipse equation. Hence the light emerging from the crystal plate, in general, it is elliptically polarized. It is elliptically polarized. This is the general equation of elliptically polarized light. This is x square by a square plus y square by b square minus 2xy by ab into cos pi equals sin square pi is the general equation of an ellipse. Let us see the special cases regarding the equation 3, general elliptically polarized equation. Here the first case, plane polarized light. When the phase difference between ordinary and extraordinary ray is 0 degree, 2 pi, 4 pi, 6 pi and so on, then sin pi equals 0 and cos pi equals 1. Here for sin pi it is taken as 0 and cos pi is equal to 1. For pi value 0, sin 0 is 0 and cos 0 degree is 1. On substituting these values in the general equation of an ellipse, that is x square by a square plus y square by b square minus 2xy by ab into cos pi equals sin square pi. For this is the derived equation already derived in the previous slide. This is the general elliptically polarized light equation. Here you can substitute the above values in this equation. We get x square by a square plus y square by b square minus 2xy by ab into cos pi equals 0. Here sin pi equals 0 because sin 0 is 0. This is RHS equals to 0. On further simplification of this equation, here for cos pi, here is cos pi value is 1, cos 0 is 1. Then this equation becomes x square by a square plus y square by b square minus 2xy by ab. This is in the form of a minus b whole square. Therefore, we can write this equation in this form. Here x by a minus y by b whole square equals 0. Therefore, on further simplification of this one, LHS of the equation, here we get plus or minus x upon a equals plus or minus y upon b. Therefore, y equals, on further simplification of this one, we get y equals b upon a into x. On cross multiply the b on RHS side, we get b upon a into x. It represents a straight line. This is straight line equation with a positive slope b upon a shown here in the diagram here. This shows that the emergent light is plane polarized in the same plane as that of the incident light. This is about the plane polarized light by applying the conditions 0 degree, 2 pi, that means 360 degree, and 4 pi and so on. We get the straight line passing from yx and y dash x dash axis here. Let us see the second case. When pi equals pi or 3 pi or 5 pi and so on, then sin pi equals 0 degree, that means sin pi 180 degree equals 0 and cos 180 equals minus 1. On substituting these values in equation 3, that is elliptically polarized equation, we get x upon a plus y upon b whole square. This is equal to 0. And further simplification of this one, a square cancelled, when it is equal to 0. And finally, y upon b equals minus of x by a, or x by a equals minus of y by b. Therefore, y equals minus b upon a into x. Y equals minus b upon a into x. And cross multiply b towards RHS, we get this equation. Here, this equation represents a straight line with a negative slope here shown in the diagram here, negative slope, that is minus b upon a. Here this dotted line indicates vibrations in incident light. Here this bold line, negative slope, indicates vibrations in the emergent light. Totally this is about the plane polarized light. The emergent light is plane polarized one with its plane as shown in the diagram. Emergent light is plane polarized one with its plane as shown here. This is about plane polarized condition. Let us see the elliptically polarized light. Elliptically polarized light. For this one, we can substitute the conditions like when pi equals, the phase difference pi equals pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2 and so on. Then sin pi equals 1. For sin 90 degree is equal to 1 and cos 90 equals 0. Then if A is not equal to B, if A is not equal to B, then the condition, you can substitute these conditions in the equation 3, that means general equation which is already derived. Then we get x square by a square plus y square by b square is equal to 1. It represents ellipse. This equation represents ellipse whose major and minor axis coincide with the coordinate axis as shown here. The emergent light is elliptically polarized for the values of pi cos 90 degree or 3 pi by 2 or 5 pi by 2. Let us see the circularly polarized light. For this one, we can substitute the conditions like pi cos pi by 2 or 3 pi by 2 or 5 pi by 2 and theta equals 45 degree. Then sin pi equals 1 and cos pi equals 0. Here sin 90 degree is 1 and cos 90 degree is 0, but in this case A is equal to B. In the above case A is not equal to B, in this case A is equal to B. Then the equation 3 becomes on substituting these values in equation 3, we get, on further simplification, we get x square by a square plus y square by a square here. Here b is replaced by a because a is equal to b, which is equal to 1. On further simplification, we get x square plus y square equals a square. Here it represents the equation of a circle as shown in the diagram here with radius a. Here a is equal to b. The emergent light is circularly polarized by obeying the condition pi cos pi by 2 or 3 pi by 2. Here theta is between these two, resultant is 45 degree. This is about the special cases regarding the elliptically polarized equation, general equation. Thank you.